Hello, everybody. Welcome back to Easy Learn, and today's topic is the sine rule. Now, as we know that if we have a right angle triangle, that means a 90-degree triangle, and if I want to find length of any of the side of that right angle triangle, then I'm going to be using the Pythagoras theorem, that's a squared plus o squared equals h squared. And if I want to find the length or angles of a right angle triangle, provided that an angle is given to me, or either I have to find out the angle, and if there are two lengths and one angle, and out of that maybe two lengths are available and one angle is missing, or one angle and one length is available and one length is missing, in that case I could use the sine, cos, tan, depending on whichever sides are mentioned, either the opposite, adjacent, or hypotenuse. So I can use the sine, cos, tan trigonometric identities. Now this only happens when we're doing, or when we're dealing with right angled triangles. Now what if I'm dealing with a non right angled triangle? A non right angled triangle means that we don't have a 90 degrees in that. All the angles mentioned in the specific triangle could be anything from 0 to 180. It could be 34, 56, 85, anything. And it doesn't have to be 90 degrees, any other angle than 90 degrees. So, in this situation, if I have a non right angle triangle, what do I deal with? In that case, I deal with the sine rule. And what is the sine rule? How would we know that in a specific triangle we have to use the sine rule? This is an important thing, that in order to be able to apply sine rule, we need to have two lengths and two angles. Now, if in any triangle we see, in any non right angle triangle, if we see that there are two lengths and two angles, now it doesn't matter if two lengths are available and out of the two angles only one angle is available and we have to find the second angle, or two angles are available and out of the two lengths only one is available and one needs to be found out. Doesn't matter which one's unknown, but as long as we're dealing with two lengths and two angles, then we should know that we're doing sine rule. Now, how exactly does the sine rule work? Let's suppose I have a triangle XYZ. So we need to know that the angle X, the length, or the place where I have my X, right opposite to this capital X, the length that is right opposite to this capital X is supposed to be my small x. Okay. Similarly, the the place where I have my capital Y, or the angle that where I have my capital Y, right opposite to that, the length right opposite to my capital Y is my small y. Similarly, my capital Z, the angle at my capital Z, right opposite to that, the length that is right opposite to the capital Z is my small z. This is a basic general concept that we're supposed to be following from now on whenever we're dealing with non right angled triangles. Like how in right angled triangles we had the opposite, adjacent, hypotenuse, but in this specific in this specific situation, when we have a non right angled triangle, we have the capital letters and small letters. And wherever is your capital letter, the length right opposite to that is going to be your small letter, the same letter but the small one. And again, what's our sine rule? If I want to apply my sine rule on anything, then it has a specific formula that is something like this: sine capital A divided by small a equals sine capital B divided by my small b. This is the sine rule. Now what's my capital A? Capital A is the angle, whichever angle I'm asking. And the small a is going to be the length right opposite to that angle. Similarly, sine B could be any angle of the triangle, but the small b always has to be the length that is right opposite to the capital B. And also, do not forget, when we're dealing with sine rule, there's supposed to be two lengths and two angles. Why? Because sine capital A, that capital A is an angle, and the sine B, the capital B, is also an angle, and the small a and small b, they're the lengths. So I'm dealing with two lengths and two angles. And it's the sine rule is used to find either length or the angle of a right angle triangle. So these are a few things that you need to keep in mind when you're dealing with sine rule. Now let's suppose I have an example like this, that this is a triangle XYZ, and my angle X is 34 degrees, my angle Z is 56 degrees. And now the length ZY is 8 centimeter and the length XY is K centimeter. Now how do I work this out? First thing, you need to realize that we're dealing with two lengths and two angles. That means I'm going to be using the sine rule. Whenever you have two lengths and two angles, you deal with sine rule. And what is the sine rule? It's something like this: sine capital A over small a and sine capital B over small b. So which one's my angle A? If I take my angle A as 34, or I could take it as angle B as well. Doesn't really matter which one you take as your A and your B, but the thing is, you need to understand whichever angle you're taking, the length that is right opposite to that becomes your small a or your small b. So if I'm taking my 34 as sine A, then the small a is 8 centimeter. And if I'm taking the 56 as my B, the angle B, then the length right opposite to that, which is K centimeter, becomes my small b. So if I write this down like that, again, sine A over small a equals sine B over small b. So in place of my capital A, if I'm writing 34, then the length that is right opposite to that, which is my 8 centimeters, comes here as my small a. Similarly, for sine for sine B, if I'm taking 56, so I replace the B with 56 degrees, and the length that is right opposite to 56, that is K centimeter, becomes my small b. Now, how do I go about solving this? So first thing that you do is that in order to get rid of your denominators, you need to cross multiply. And by cross multiply, I mean the 8 goes on the right side and the k goes to the left side. So when k goes left, we have something like this: k times sine 34. Why am I timesing? Because k is in division over here with sine 56. So when it goes to the other side, it turns into multiplication. Similarly, when 8 goes to the other side, again 8 is in division. With the sine 34, it goes to the other side, it turns into multiplication. And I have something like this: k sine 34 equals 8 times sine 56. Now, if I put that stuff in my calculator, make sure that your calculator is set on degrees. And then if I write down 8 times sine 56, I have something like this: 6.63. So k sine 34 equals 6.63. And then because I have to find my k centimeter or the length, so I have to take the sine 34 to the other side. And what happens when sine 34 is going to the other side? This k is in multiplication with the sine 34. So if sine 34 is going to the other side, it turns into division. So 6.63 divided by sine 34. And again, on your scientific calculator, make sure you're set on degrees. And if you write that down, 6.63 divided by sine 34, your answer is supposed to be something like this: 11.8563, and so on. And then you got to round it up. So k equals 11 point, if I'm rounding up to one decimal place, I can just do 11.9 centimeter. So this length, that is the XY length, becomes 11.9 centimeter. So all you have to do is just figure out which one you're taking as your A. Once you have figured that out, then the length that is right opposite to A becomes your small a. Similarly, you equate it with the other angle available, and the length right opposite to that becomes your small b. And then you just go on solving the equation and you'll get your answer. Let's look at another problem. Let's suppose I have another triangle again, XYZ, where my x is 28 degrees and my z is k degrees. And the length ZY is 22 centimeter and XY is 14 centimeter. Now again, keeping in mind that if I'm dealing with two lengths and two angles, it's the sine rule. So the sine rule says sine A upon A equals sine B upon B. Now, notice in this one, where I have my sine 28 degrees, the length right opposite to that is 22 centimeter. And where I have my sine B, is it's k degrees. So the length right opposite to k degrees is 14. Doesn't matter which one are you taking as your a and as your b. Like I could also take my k degrees as my sine a. So in that case, if I take k as my sine a, then the small a becomes 14. Similarly, this if I'm taking k as my sine a, so 28 degrees becomes my b, the sine b, and then the length opposite to that, that's 22, becomes my small b. So either ways, you can decide which one are you taking as which one. Now, if I put that up there, sine a over a equals sine b over b. My sine a, if I'm taking as 28, then the length right opposite to that, that's 22 centimeter, comes down there as my small a, and then the capital B comes as the capital K, because that's the degrees that's unknown to me. And the one on the bottom, that's the B, is replaced with 14 because the length right opposite to the capital K is 14 centimeter. Now, how do I solve this? So first thing I'm going to do is just simply do sine 28 divided by 22. I could do that first, so that because I have everything available on one side, on the left side. In the previous question, I was one of the denominators was missing. That's the reason I took everything. I mean, I cross multiplied, but in this one, I don't really need to. I mean, if you want to, you will only cross multiply the 14 and take it to the other side, and then it continues. But for now, first thing I'm going to do is I'm just going to do sine 28 divided by 22. And if I do that, first thing, make sure your calculator is set on degrees. So sine 28 divided by 22 gives me 0.021 and so on. So I'll just write 0.0213 equals sine k over 14. Next thing is that I gotta get rid of the 14 over here because I need to find my k in the end. So whatever is attached with the k goes to the other side one by one. So when 14 goes to the other side, it becomes 0.021 times 14, because 14 is in division over here, goes to the other side, turns into multiplication, and 0.021 times 14 equals the sine k. So if I do that, 0.021 times 14, it gives me something like this, 0. Oh, sorry, 0.294 equals sine k. Now, since I want to find my k, I need to obviously isolate my k. And if I want to isolate my k, I have to take the sine to the other side. And as discussed earlier, when sine goes to the other side, it turns into sine minus 1, or it's also called sine inverse. So sine inverse of 0.294 is equal to my capital K. So if I do that, now again, first thing, make sure that your calculator is set on degrees. Secondly, you have to click inverse I and V. Once you click that, you have sine minus 1, cos minus 1, tan minus 1. And because I'm dealing with sine, so I'm going to click sine minus 1. And when you write that down, you can see you have arc sine, and then you put 0.294. That gives me something like this, 17.097, and so on. So I could just round it off and write my K, the capital K, as 17.1 degrees, which means that this angle Z right here becomes 17.1. So again, all you have to do is try and remember the sine rule formula, that's sine A over small a equals sine B over small b, and make sure that you do not mix up between which lengths and which angles to take. Whichever angle you're taking, the length right opposite to that becomes the smaller version of it, and then you just keep on solving like a normal equation. So that's pretty much it. Hope you understood all the concepts, and if you have any questions, any confusions, just drop them down in the comment section below. Thank you so much for watching Easy Learn. Do not forget to like, share, and subscribe. Thank you so much. Take care until next time.